So these are my three books. And as I said, the blue book, which is machine learning and deep learning, I intend to use as a textbook, but there is no compulsion. If you listen to my classes properly, and if you take notes and if you follow the exercises, I think you don't need any book apart from my video lectures. And all the videos will be available on my YouTube channel. Okay, so anyway, if you want to follow that, there will not be any, don't need any book basically. Then I want to tell you first, like there are some terms which are very closely related, like data science, machine learning, and artificial intelligence. So data science, machine learning, and business analytics. Listen once again, data science, machine learning, and business analytics. These three terms are very synonymously used, like they are interchangeably used. We use one term for the other. Okay, we use one term for the other. And so they are very interchangeably used. And artificial intelligence also is similar term, but we use it in the sense of advanced topics like deep learning and natural language processing. When it comes to that, problems are same type, like regression and classification, but they are solved using deep learning and other advanced techniques. So that time we'll refer it as artificial intelligence. There are two older terms, like one is data analysis and business intelligence. Business intelligence is a very older term which was existing in 1990s also when I was studying in college. So business intelligence means just making some dashboards and doing some basic calculations, presenting the data summary and all to management. Data analysis, anything you do on data is data analysis. But in machine learning and data science, specifically we do predictions and classifications. Okay. So these are specific to business analytics and machine learning. Okay, so business analytics, machine learning, and artificial are definitely more advanced than business intelligence. Okay, so these are the similarity and dissimilarity you should remember. Now I want to tell you like what is business analytics, and machine learning. So I'll write it as machine learning as well. Machine learning, like all of it is business analytics. If you are you are a basketball coach, you are recording a lot of matches, okay, and while training your other players, while training your team, you are analyzing, like you are predicting or analyzing like basketball player's next move, like what will be its next move, where he will pass the ball. So that kind of study, like it is prediction, right? So you seeing the past videos of that basketball player, you want to analyze, you want to tell what will be the next move. Then you are studying a website like Amazon.com, and you are studying its numbers, website numbers, traffic numbers. You are studying website traffic numbers. You are studying website traffic numbers, and then you are projecting for next 3 months what will be the traffic pattern, what will be traffic numbers, and what will be the traffic pattern. You will ask me what is the advantage. Advantage is, suppose Amazon comes to know that next 3 months my number of customer will increase or decrease. Which week or which month number of customers will be more. So they can arrange more infrastructure to handle those kind of more traffic. They can arrange in the cloud. They can arrange more infrastructure. They can deploy more support people to handle that kind of traffic. So management can take decision based on this predictive analytics. Okay. Now, like a restaurant chain is there, any restaurant chain is there. You are predicting for them that for the next 3 months, what will be your earnings, how much money you will earn, you are going to earn in next 3 months. So if you are projecting that your earnings will be 40% higher than your average monthly income, you will be earning 40% higher. What does it mean? 40% higher means more customers will come, right? So restaurant will be able to make more that arrangements. They will deploy more people. They can stock more raw material. So those kind of decisions they can take based on this intelligence that you are giving to them. Okay, so that's how we use business analytics. Okay, so business analytics. Now I am coming to a formal definition. Business analytics and machine learning. I will say and machine learning. Machine learning is all about understanding data. So data is central to machine learning. You have to understand the data, and you have to make smarter decisions. You have to make smarter decisions based on relevant information extracted. Like data is not useful, raw data is not useful. Suppose I give you a very big Excel file. So the Excel file is 15 MB or 20 MB. Lot of data rows are there, lot of data elements are there in that. So looking at data, you will not be able to make any sense out of that data. So what you have to do, you have to do exploratory data analysis. You have to plot that data. You have to plot some trend curve. You have to plot some bar charts. You have to plot some pie charts and understand what kind of data you have. Once you have that kind of data, then you apply some kind of predictive analytics or classification, and then that kind of classification and prediction when you apply, that kind of classification prediction when you apply, and those exploratory data analysis dashboards and charts which when you put in front of management, they will be able to make smarter decisions. So smarter decision, what is the basis for making smarter decision? So basis of smarter decision basis is data. Data is the basis for making smarter decision. So how they are making smarter decision? So raw data, not using raw data. So first they are processing it. They are finding out relevant information from that data. Okay, and they are finding out relevant information, relevant data patterns, and they are exploring the data. And based on that relevant information, they are making smarter decisions. So smarter decisions may be like if like market demand is going to be more. Like for HP only, I will tell. Market demand is going for laptop is going to be more, like it was there in during COVID years. During COVID years, HP was not able to fulfill the laptop demands in the market. Okay, because supply chain was not able to fulfill the demand. So if they come to know previously in advance only, they come to know that there is going to be demand is going to be more. They will order their factory to manufacture more and stock it. Okay. So those kind of decisions can be taken in advance if they know what is going to be there in the future. So management can take advanced decision. So what is the use of taking those advanced decisions? Smarter decision, they will be able to make more profit. Their revenue can increase. They can make more profits. Okay, that's what is the aim of any enterprise. So aim of any enterprise is to make profits, right? So I will stop here for a minute, and if anybody has any question, please unmute yourself and go ahead with that. Anybody, any questions? Any query, any type of query? So I'll stop, keep stopping in between and give you an opportunity to ask questions, okay? So I want it to be as interactive as possible, and you are encouraged to ask questions, you are encouraged to make comments. If you have any comments till now, you can tell me, yes, I think so, or I have this kind of questions. So you are encouraged to ask questions, okay? So now I go ahead because I don't get any questions. So business analytics or machine learning is an interdisciplinary field. So it requires business knowledge, it requires statistical knowledge, then it requires and business knowledge is not only business knowledge is required. Business knowledge is required from many business domains. Okay, and after this, I am not going to give entry to anyone, I think. So business knowledge is required for many domains: marketing, sales, or say retail, or say finance. Many domains are involved, and underlying thing is only data is very important. And to analyze that data, we need statistical tools. Statistical tools are required. Information technology is required. Computer science is required to carry out any business analysis, machine learning, to solve any business learning problem. You need information technology, computer science. You need statistical tools. You need business knowledge. So lot of like business domains come together, and then only we are able to analyze machine learning problems. Okay. Then what kind of tools you need? So business knowledge is the extensive use of data. So we extensively use data in business analytics. We use data extensively. Then we make extensive use of statistics and quantitative analysis. Then we do a lot of exploratory and predictive models. Predictive models means we do projections in data. We do exploratory data analysis. I explained to you, make so many charts to understand the trends in data. And then we do fact-based management to drive decisions and actions. So once we do all of it, all first three steps we take, then based on all the first three steps, we are able to make derive better decisions. Okay. So you can, as you can see, like it is business analytics interacts with many domains, like as you can see in the picture. Now, three main ingredients of business analytics. So there are three main ingredients. Most important is quality data. Second most important is business
Yes,
or
sir.
domain knowledge.
Sir,
Yeah,
sir,
please go ahead. Yeah.
sir, I think someone reshared the screen, so now it's on your video rather than the presentation.
Someone
Just,
reshare. Okay.
put reshare your screen,
Okay.
cancel it and reshare.
Resume presenting.
Yeah. Okay.
So the most important and quality is ingredient is quality data. You should have data and quality data. Okay, if you put junk inside, your analysis will also produce junk only. Okay, then you must have relevant business knowledge. If you are working in, if you are applying business analytics or machine learning problem to finance domain, you must be expert in finance domain. You then third important gradient is statistics or algorithms. All analysis is carried out with the help of statistical algorithm. Now, if you ask a question, what is important? Data is important or algorithms are important? So it is established fact that data is always more important than algorithms. Okay, or means data is the most important ingredient as far as business analytics and machine learning is concerned. Okay, so data is most important. Data is much more important than algorithm itself. Then why should you study business analytics? I'll give you only a couple of reasons. You get great pay packages in business analytics, and business analytics offer a future-proof career. Like this data, this is the age of data. There is a data explosion everywhere. All websites, all tech websites are generating data. Okay, so this data analysis is never going to go anywhere. So it is going to stay forever. But only analysis methods will be simplified. Right now, we are doing coding to do the analysis. As we 10 years down the line, 20 years down the line, requirement of coding will be less. And you are getting great pay packages in business analytics. That's why you should learn. And one example I want to give you in Amazon, Google, Microsoft, Apple, or any technology company you take. The best paid professionals are data professionals and business analytics professionals. They are the best paid guys. Okay. So these results should be enough for you to learn business analytics. Okay. Then what tools are required? Skill set required to be a good machine learning or business analytics engineer. You should be well versed in Excel. Excel is Microsoft Excel. You should be very you should be master at that, and you should be master at SQL. So SQL will not be covering, and Excel also will not be covering. But you are expected to know Excel as well as SQL. Then you should be proficient in tools like Tableau or Power BI. So Tableau or Power BI also we are not covering because these tools are used for data presentation, the exploratory data analysis or making dashboards or those kind of things. These two tools are there. So if you are a business analyst or a machine learning engineer, you are expected to present data using Tableau or Power BI. Then you should be proficient in Python or R. R is a language, another programming language. Python is a programming language. So we will be mostly working with Python in this course. Then you should be adept in data visualization because whatever you develop or whatever analysis you do, you should be able to present it to the management in a visual form. Okay. Udesh, my screen is visible, right?
Yes, sir.
Yeah. So in this basic machine learning course, prerequisites are basic or R programming. So basically, mostly we'll be working with Python. Python is a programming language. And I expect you to know a bit of statistics like mean, median, mode, mean deviation, standard deviation, correlation coefficient, those kind of basic things I expect you to know. But whenever it comes to those kind of terminology, I'll cover that, I'll explain that. Then what we'll cover in this course is that BA, like business analytics. Business analytics, I am using synonymous to machine learning. So business analytics specific Python libraries I will be covering. Tableau resource I will be giving you from udemy.com. So I will ask you to, if you wish, you can subscribe to a 10 hours Tableau course from udemy.com, which is just less than 500 rupees. In that 10 hour course will make you master in Tableau. Then in this class only we'll cover theory behind all the statistical algorithm used in our course. All the theory behind all the statistical algorithm we'll cover in this class. We'll cover Python programs for all the algorithms. Python programs also we'll cover, and most important thing is that we'll cover how to derive business outcomes from our data analysis. Whatever we do here in step 3, 4, 2, whatever we do, why we do it? We do it to derive business outcomes, right? Actionable business outcomes. Okay, so I'm writing it here. Actionable business outcomes. Okay, so actionable business outcome means whatever analysis you do or whatever recommendation decision you make, or whatever recommendation you make to the management, they should be actionable. So they are quantitative, they are not qualitative. That you increase sale, your profit will increase. Not like that. We'll tell them you increase the sales by X percentage, your profit will increase by Y percentage under current market condition. So we'll tell all of these in quantitative terms. We'll tell them. So this is the aim. Point number 5 is the ultimate aim of our analysis or business. Any business analysis, it is the ultimate aim. Okay. So this is how it is. Now I want to give you a very layman's picture, like how business analytics or machine learning works. Okay. So now you see this. There is a dog. It's a pet dog of the family. It's a pet dog family. A newborn baby girl. Baby is sitting first time near to the dog. Baby now recognizes dog, and she is familiar that 2 eyes, nose, mouth, 4 legs, and this kind of animal is something like dog, which plays with me. Very small baby, not much understanding. So plays with me. So that's what she understands. Okay, and she is plays with this pet dog for a couple of days or a couple of weeks, and after that their family brings a small puppy for her, a small puppy which is shown on the right hand side. So this kind of small puppy they bring from this baby. So now this obviously baby is very small, so baby has never seen the puppy. Okay, so baby has never seen the puppy, but with her experience with the pet dog of the house, she understands that this puppy is a dog because it has similar features. She has 2 eyes, nose, 4 legs, and it plays similarly in the similar fashion as a pet dog plays. Only thing is it is smaller. Even if it is smaller, color is different. It is able to baby is able to still make out that it is a baby is still able to make out that it is a puppy. So what is first? Left hand side, when baby is sitting with a pet dog for the first time, it is nothing but machine learning algorithm training with historical data. So baby is nothing. Baby we can equate with machine learning algorithm, and the pet dog we can equate with the historical data. So we are training baby to recognize a dog. This is nothing but training of machine learning algorithm with historical data. This is the first part. So historical data is required. Business analytics algorithm is required. Okay, so this is training is done. Once the training is done, when small dog comes, even if it is very different, baby is able to recognize. So what is in our terms? What is it? It is machine learning generating results from previously unseen data. Listen once again. Machine learning generating results from previously unseen data. Baby has never seen the dog before, but baby is still able to recognize that it is a dog. Okay, so it is BA. BA means we are equating BA with baby. Okay, BA with baby mind we are equating. We are business analytics we are equating with baby mind. So baby mind is recognizing. So how it is recognizing? Because she has seen baby before. We had trained her to see the dog and play with the dog before. So this is how our machine learning works. You need historical data first to train the algorithms with historical data. Once algorithm training is over, it is able to work on. It is able to do predictions on unseen data as well. So this is how it works. So I have given in very layman terms. We have not talked about data. We have not seen any data element in this. It is a very simple example I have tried to give to a very layman. Even a layman will understand that what is machine learning. Okay. Now I will cover it later. So like the guys who are a little experienced and with little professional background, so I will tell that there are many applications of data science. So data science, I'm again using synonymous to machine learning. So we use it, banks use it for risk analysis, consumer analytics, fraud detection. So fraud detection, I will explain you. Like 1 year, suppose one bank is having a lot of credit cards in the market. So that bank will have some millions of credit card transactions, because one person does at least 10 to 15 transactions a month. So they have thousands and thousands of credit cards in the market. So all number of transactions will be in millions. So 10 lakh transaction, 20 lakh transaction in a month they will have. So yearly it will be run in crores. Number of transactions will run in crores. Okay, so a lot of, I mean to say that bank has a very large number of transactions which are belonging to their bank, their credit card customers. Okay, so they are having a lot of transactions. Meaning is that the bank is already having historic data. Now, out of those transactions, some transactions are fraud, because they are done by cheater people, or they are done by fraudulent people. So some transactions are fraud. So less than 1% of total transactions, let us say, are fraud. So bank knows, because it is a historical data, bank knows which transaction was fraud and which transaction was genuine, which transaction was good and which transaction was bad. Bad means fraud, genuine means good. Okay. So bank knows which is good transaction, good data, good transaction, which is bad transaction. Bank already knows, and bank has that historical data. So we'll train one machine learning algorithm and we'll teach machine learning algorithm will learn mathematically to recognize bad transaction. Machine learning algorithm will recognize machine learning algorithm will learn to recognize good transaction. How it will learn? Based on the attribute like which place the transaction is carried out, which shop the transaction is carried out, which country the transaction is carried out, what time the transaction is carried out, and what are the customer demographic details. Suppose till yesterday, Shailendra Kadre was doing transactions in Bangalore, and suddenly one morning, 5 o'clock in the morning, 5 o'clock India time in the morning, one transaction is happening from USA. So yesterday night till night 10 o'clock, Shailendra Kadre was doing transactions from Bangalore, and morning 5 o'clock India time, the transaction is happening from USA. So bank will come to know, yeah, how is it possible in 5 hours or 7 hours? How can Shailendra Kadre travel to US and do transactions there? So immediately in the real time itself, bank will recognize that this transaction is fraud. So bank will block that transaction. Bank will not allow that transaction to proceed. And one more thing bank will do, bank will block Shailendra Kadre's credit card. Why? Because bank has discovered that this credit card has been copied by some bad people, some fraudulent people have copied this credit card and they are using it somewhere in the US. So they have copied credit card in India and electronically transmitted the details to US. They have made a copy of their credit card in US and they are trying to use in US websites or US retail stores they are trying to make. So bank will fraud. The bank will block the credit card. So bank has successfully saved their money. Okay, because what is fraud? Fraud means bank will lose a lot of money, and all fraud transactions, if you sum up, every year banks lose millions of dollars, millions of rupees, millions of dollars are lost by banks. So in real time, if you are able to tell banks whether it is a fraud transaction or it is a good transaction, they will save millions of rupees. So how they are recognizing? Based on the features, based on the variables. That Shailendra was till yesterday, location is a variable. So till night 10 o'clock yesterday, Shailendra was in Bangalore, and morning 5 o'clock the transaction is reported, location is changed from Bangalore to New York. Not possible. So they will block. So like this is only one attribute I am telling. So with every credit card transaction, there are say 20 or 30 this kind of variables are associated. So when we are training our machine learning algorithm in historical data, so based on these 20-30 variables, machine learning algorithm mathematically learns. It learns mathematically. Okay, mathematically it learns to classify between bad transaction and good transactions. So this is one use in finance I told you. Another use is in the medical healthcare field. Like healthcare field, one simple example I will give you. Like one doctor, like any big people you go like Prime Minister or Chief Minister. You might have learned from newspapers that never a single doctor is appointed to treat a chief minister or a panel, any VVIP like prime minister or chief minister. Never a single doctor is appointed to give his treatment to these kind of people. Always a team of doctor is appointed. So a team of doctor will treat chief minister, a team of doctor will treat prime minister. Why they do it? Because a single doctor can do mistakes. But if I have appointed 5 doctors and out of that 3 doctors are telling the treatment should be done this way, or chief minister is having this kind of disease, the chances of error are less. So instead of appointing multiple humans, what I will do is I will still appoint human doctor to treat chief minister, but along with that I will appoint one computer program which is machine learning algorithm trained in health records. All kind of health records, historical health record, I have trained that kind of machine learning algorithm. So that kind of machine algorithm is running on a computer, and now that is assisting doctor. So all the chief minister's current symptoms are there. He is having fever, he is having cough, he is having cold, he is having headache, whatever his symptoms he is reporting, all the symptoms are fed into that computer program. Computer program is telling that probability 80% corona, probability 60% viral fever, probability 40% just normal cough or cold. These 3 probabilities it finds out. So what is the highest probability? Highest probability computer is telling 80% corona. So now computer with highest probability of 80%, computer is telling that it is a corona disease. It is a corona, chief minister is infected with COVID-19 virus. Okay. Now that results will be intervened by one very able or qualified doctor, and then he will finally decide. Computer is telling these 3 diseases, and I am using my experience. I am also examining doctor, clinically examining doctor. So based on my experience and computer experience, together I will decide that what is the disease and what kind of treatment should be given to the chief minister. So here machine learning algorithm is assisting doctor, right? It is the application in healthcare. Then I will give you one example from like Amazon. Like say one gentleman is purchasing shirts from Amazon. You purchase some shirts, couple of shirts, and as soon as you purchase shirts, Amazon will give you below some recommendations that along with these shirts, people also purchase these kind of trousers. So these 3 trousers, Amazon will show you that these kinds of trousers are suited for the kind of shirt you have taken. So you will forget, with the shirt I need a trouser also, right? My trousers have gone old, so I need a trouser. So it is showing Amazon program is recommending you some product, good trousers, which fit which are matching to your shirt. Then what you will do? Your chances of purchasing one of the recommended products means one of the recommended trousers are higher. So how you purchase a book? Invariably, Amazon will give you one recommendation that people who purchase books XYZ also purchase these books. So he will giving you 4 or 5 books more. They will show you related books. So there is a chance that one of these 5 books also you will purchase. So Amazon is increasing revenue with the help of what is this? So behind every these things is a machine learning program. So how that machine learning program is working. Left hand side of this PPT you see, I am making PPT full screen. So left hand side of this PPT you see there is a table. One is transaction ID, one is item list. What is transaction ID? Transaction ID is random customer number. Customer number 1 purchase cookies, egg, milk and sandwich. Customer number 2 purchase bottled water, burger, chicken, egg, pizza and salad. Customer number 13 you purchase bacon, bottled water, egg, fries, pizza, sandwich. Customer number 15 purchase bottled water, burger, chicken, egg, pie, pizza and salad. So this is a random transaction, whatever customers have purchased. This is the raw data is entered in Amazon systems, Amazon computer systems. So what nice people like us, business analysts or machine learning engineers, they will do, they will train a machine learning program on this kind of data. That if a person purchases egg and milk, that there is a high probability that the person will purchase bread also. So person is purchased egg and milk, and he is trying to log out. He is trying to go for payment. Before the payment itself will recommend, yeah boss, you have purchased egg and milk, but the people who have purchased egg and milk generally purchase bread also. So there is a very high probability that you have forgotten bread, so we'll purchase bread also. So these are called recommender systems. So this is how like Amazon trains their recommender systems on this kind of raw data. And Amazon is having kind of millions and billions of these kind of transactions of every customer, from like a worldwide customer. They are having this kind of. So for every geography, they can for every geography like India, UK, US, they can run this kind of recommender system. And Amazon.in, Amazon.com, so they can have separate recommendations. Same product, same book if you purchase on Amazon.com, recommendations will be different. Same book you purchase on India, recommendations will be different. So like that, localization also happen. So this is nothing but machine learning or business analytics in retail. Now everyone goes to McDonald's or KFC, right? What we do, like we purchase French fries and one burger, purchase separately. Bill is 150 rupees. Bill is 150. Let us say bill is 150 rupees. So immediately that the counter boy who is billing for you, he will get a recommendation that this guy is spending 150 rupees. But our meal combo one is just 140 rupees. Customer will get these two. Customer will get fries and burgers. But along with that, in 140 rupees itself, he will get one Coke also. So immediately that counter boy will tell you, boss, instead of purchasing these two separately, you go for our combo. You will get Coke also. What? You are very happy. You save 10 rupees. Boss, you got one item extra, because you always need some kind of Coke or Pepsi with this kind of food, right? People always go for it. So this is nothing but called market basket analysis. This is the use of business analytics in retail. No, not in retail, fast food restaurant chain. So business analytics is like kind of applicable in every field where you have data. Any field where you have data, be it science, be it engineering, be it finance, retail, restaurant chain, or any damn business where you are having data, you can apply HR, human resources, where any damn thing where you have data, you can apply business analytics and get some nice useful recommendation where you can increase your revenue, you can increase your profit, you can increase your customer satisfaction, you can increase your number of customers. Like that, many things can happen. So this is the use of data to improve the business. Okay. So now on this, I want to give one say 2 minutes break. And if you have any kind of questions, you can ask me. Or if you have any comments, any questions, you can ask me. Any comments, any questions? Whatever I taught was very simple, but if the guys are new to machine learning, I think these kind of things may go overwhelming, like a kind of they may think these are too many new things are being bombarded. So I want you to give you opportunity. I want to give you opportunity to ask questions. So any questions? Anyone? Malini madam, any question?
No, sir. No questions.
Going on good?
Yes, sir. Going on good.
Yeah. Okay. So now with this we'll go little technical, bit technical, very bit technical, not very much technical, very bit technical. Now, what kind of machine learning problems you have? Machine learning problems are divided into two categories: supervised and unsupervised. So what is supervised? What is supervised category means? Supervised learning means historical data is needed both in supervised and unsupervised. But what is supervised? Let us come first. Supervised means you see this kind of neural network. This is also a machine learning program. This is deep learning program. Basically, it comes in the category of AI. Okay. So you have historical data. So historical data is what? You have images of, you see the left hand side, the toy images of a dog, cat, finger. So like this, these kind of images you have. But there is one more thing. You can recognize that this is dog. You can recognize that this is cat. You can recognize that these are two fingers, victory sign. But how computer will come to know? So for that, what we have done, we have labeled these images. We labeled means we have in data itself, there is one column, what this image represents. So image one in data field one, image one is there. So in data field 2, I have data field 2, I have put it label. So data field, my label is like cat, dog, and victory sign for these 3 images. Like that, I have say some 1,000 rows or some million, some 1,000 rows or few lakhs of rows. I have. For every image, I have a label. So I tell computer that what is that image it represents. So I have label also. Label is very important here. So I have data also. Like the image is my data. Image is nothing but data. Image is called unstructured data. Image is unstructured data. You don't go into that. That will come later. But image is data. Okay, image is data. Label means I'm telling in the data itself, I'm telling computer that this is dog, this is cat, and this is a victory sign. Now, what I do, I feed all of this data into this neural network. Neural network is nothing but a computer program, a machine learning program. So what the computer knows the image also, and the computer is given label also that this image represents dog, this represents cat, and this image represents a victory sign. So with all these inputs, our computer program gets trained. Training happens. Training of computer program happens. So computer type program learns to recognize a cat, dog, and a victory sign. So next time you bring a little different pictures of cat, little different of pictures of cat also. Not necessary that you should bring exactly the same picture. Now here you have the cat face, but if in the other picture you have cat sitting, full picture of the cat, where is the cat sitting on the bench or something? You feed into the computer will, our machine learning program will be able to classify it as a cat. So how it is classifying? Because we had trained that computer program in labeled data. Labeled the data. Data was having labels. Historical data was having label. So label is very important. So when we train with labeled data, our historical training, when we do with labeled data, it is called supervised learning. Okay, so if anybody is giving you these kind of images, cat, a cat, dog, or victory sign, they will never give you that what kind of images they are. So somebody has to sit manually, like you and me, like some person has to sit manually and label them that this is cat, this is dog, and suppose there are 1 lakh or 2 lakh records, so all the records have to be labeled manually. This is a painful job somebody has to do. Then only computer program, then only our machine learning program training will happen. So somebody has to sit manually that 2 lakh or 10 lakh programs are there. So all one by one, they have to label it. This is dog, this is cat, this is victory sign, this is number 5 sign, this is a car, this is truck. So all somebody has to, this is a very trivial task, very simple task, but somebody has to do manually. And imagine suppose you have 1 million records, 10 lakh of records. So how painful it will be. But somebody has to do that job, and otherwise our training of machine learning program will not happen. Machine learning will not be, our program will not be able to classify which is cat, which is dog, because we are not done the training. So this is supervised learning. One example. Another example is unsupervised learning. Like I just feed in this image, like left hand side I have an image, I just feed in this image. And I don't tell computer which one is which vegetable. Like one is potato, and two other kind of vegetable I can see. Like 2 other kind of vegetable. There are 3 kinds of vegetable in this. So I don't tell computer. I don't label. I don't tell computer which kind of image belongs to which kind of vegetable. Vegetable 1, vegetable 2, vegetable 3. But I don't tell computer this. I feed only this image. I feed computer only this image without any labeling. So what computer program? This is clustering program. This is clustering type of problem. So what the computer program will do, based on the color, shape, average shape of shape, weight, shape, color, based on these attributes, automatically it will place this image into separate into this three kind of this kind of image, like separate. It will separate out vegetables. Okay, it will separate out vegetables in 3 groups. Here only 2 groups are shown, but right now I can see 3 types of vegetables here. So you will get 3 groups here. So computer program will be able to cluster itself. So this is the kind of problem which is applied in customer segmentation, like customer segmentation in human resources and all that, where we don't do any kind of labeling, but based on the variables or attributes or features involved in the data, computer is able to cluster them in similar kind of things are clustered similar. So there are 3 kinds of vegetables, so there are 3 clusters will be formed. So when we don't give any label, and ask computer to do some kind of segregation or separation, then it is unsupervised learning. So this is nothing but a clustering problem. So now I want to, with this, I think I have almost come to the end. I want to give two formal definitions. So one clustering definition I have shown you here, right? This clustering, we are not, though it is a part of traditional machine learning, will not be covering in our 2 weeks course because of time constraints. But we'll be definitely covering classification regression. So what is classification type of problem? You are given pluses and these dots, blue dots and blue plus signs, you are jumbled up, they are given up. Okay, so given a new symbol, you have to classify it whether it is plus or it is a dot. It is a ball or it is plus sign. First we'll train the computer program, and then once the training is done, I will give you a new symbol. I will not tell you whether it is plus or a ball. So computer program has to classify whether it comes in plus category or whether it comes in ball category. So either you can put plus as positive class and ball as negative class. 0, 1. So 0 means ball and 1 means, in computer terms, computers everything is numeric, right? So 0 means ball, 1 means our plus. Like that we classify. This is classification problem. Yes, no. Transaction. Transaction is either fraud or good or bad transaction. So good means 1 and fraud means 0. So computer will classify. Computer tells 1 means we have to understand it is a good transaction. Computer will tell us, machine learning program will tell us it is 0, means we have to understand it is a bad transaction. So like that, when we do some kind of classification, so then it is a classification problem. So logistic regression, there is a very basic technique called logistic regression is used in classification type of problems. Now regression. Regression means now you see these balls. This is not classification. What is this? There is a line which is going up, a slanting line which is going up. So what is this? So it is said that it is housing prices from year 1947 till 2020. I have data of housing prices in Bangalore. So 1947, naturally the prices will be less, and 2020 the prices will be more. So like that we have fitted a line. So like that dots will be there for different price. One dot belongs to one price point. So like that we have fitted one line. So this line represents a general trend. Okay. So now what happens? Now I will ask you projection. What will be the housing prices in Bangalore in 2021-22? What you will do? You will simple this slant line. This slant line is there. You will extend it to 21 and 22. So based on this slant line, you will be able to predict what will be the approximate prices in 21, what will be the approximate prices in 22. So here there is a difference. In classification, we are dealing with only 0 and 1 classification. But in regression, we are dealing with continuous numbers. House price in for 1947 was say 4,000 rupees. In 2020, it was 4 lakh rupees. And I predict that in 2021 and it will be around 5 lakh rupees, and 2022 it will go up to 6.5 lakh rupees. So we are dealing with numbers, projection of numbers. So this kind of problem is called regression. So there is a very basic regression, the very basic machine learning algorithm used for this is linear regression. So linear regression is used for projecting numbers, and logistic regression is used for classification. So these two techniques will cover. Apart from that, there are a number of machine learning techniques, and every technique has its pros and cons, positives and negatives. But linear regression and logistic regressions are two most basic techniques. Linear regression for projecting numbers, logistic regression for classifying, say yes or no, fraud or not fraud. So these kind of things. So these linear regression and logistic regression, almost everyone should know. That's why we are covering it in first 2 weeks. And for me, there will be total 6 classes in first 2 weeks. So I can cover only this much. And I will give one assignment also in Python assignment. Okay. So that will give you a complete idea of how machine learning training happens, how predictions are done, how accuracy is calculated, how effectiveness of a model is calculated. All these things will be clear to you when I will explain you the code in the class and when I will be giving you assignment. So that which you have to do yourself. Okay. So everything will be in Python. It is very simple. Nothing to worry. I will give you, once I will explain that explain one problem in the class. Full code I will explain. Same code, based on same code, I will give you another data set. For data set 1, I will explain the code. Then code will remain the same. Data set 2, you have to use the similar code. Data set 2, you have to use the similar code and solve the problem. So that reference I will always give it to you. So I have covered the supervised problem, unsupervised. Then I have covered what is machine learning. Then you should know what is data science, what is machine learning, what is AI, what is business intelligence, what is data analysis. So these all things I have covered today. So, supervised and unsupervised techniques I have covered. And now, like let us come to a little bit management side, like sector-wise management analytics. Analytics means you read analytics as machine learning. So you will see that in the pie chart, which is on the right-hand side, you will see that retail and consumer packaged goods, like retail industry, like Amazon.com or Flipkart or Reliance Retail, Reliance Smart, those kind of companies. Around 38% of those companies are very heavily using analytics or machine learning. After that comes financial services, banks, stock broking companies, stock exchanges. So these are the financial institutions which are second biggest users of analytics services. That is 20%. And after that, third is telecom. Telecom means your telephone companies like Airtel or Idea or BSNL. Those type of companies are the third biggest users of analytics. Then fourth number comes is healthcare. Healthcare means hospital, your pharma companies. These are the fourth biggest users of analytics. Then all others will come together is 16%. So all other means what? Left-hand side I have shown a graph like energy utilities, film production, travel and logistics, gaming. So gaming industry also using significantly. So gaming industry 6% of gaming companies have adopted analytics. So this is just a kind of feel you should get that what kind of where I can get job after doing analytics. If I master machine learning or business analytics, where I will get job. So you are likely to get job number 1 in retail and like Flipkart, Amazon or Reliance Smart or those kind of things. That is number 1. If not retail, you are likely to go in banking and finance. If not that, you are likely to go in telecom, then healthcare, and then there are other fields which are together. So this is just a information slide, and this one thing I want to tell you just kind of some nitty-gritties. So it is 80% hands-on and 20% theory course. It is going to be 80% hands-on course. There will be very less theory. Only today's session was the theory. Going forward, theory will be very less. So it will be going to be 80% hands-on. Hands-on means Python coding. 20% of this course will be theory. You are expected to code in Python or R, but R we are not covering, only Python. You are expected to code in Python throughout till the course completion. You have to code in Python. Be prepared for that. And certification exams will be only theory based. Certification exam, no coding will be asked. Okay. Whatever certification exam will take at the end will not ask any coding. Not a single code will ask. Not a single piece of Python will ask. Will ask only theory. Because these are the interview questions which companies will ask you in the interview if you want to get into any analytics or machine learning company or any IT company. And what I expect, I don't want to be a super duper intelligent. If anybody is just average but hardworking and sincere, so you can successfully complete this course. Average guy but hardworking. Work is important. Like sincerely you have to work, timely you have to work, on time you have to work, and sincerely you have to work, and you should be a bit of hardworking because coding is always hard work. Coding you cannot do like say sit half an hour and you can do. So for say 3-4 hours together you have to sit on bench and do coding on the machine. That is always, coding is always like that. So coding requires some hard work. And what kind of intelligence I expect from you? I expect you to be only average. If you are super intelligent, then okay, no problem. But even if you are average, you are okay. Okay. So that's where I am. And my last slide, like 7 hands-on skills which you will gain on the completion. Which skills gained on when you will complete the course, you will get these 7 hands-on skill. One is pre-processing of data for analysis, exploratory data analysis for discovering patterns and trends in the data, exploratory data analysis, then data visualization in Python, then apply business analytics to various functional areas. I'll be giving you assignments from telecom, I'll be giving you assignments from HR, I'll be giving you assignment from like atmospheric sciences, I'll be giving you assignment from housing prices, I'll be giving you assignment from retail. So various functional areas will cover in various assignments. So you will learn how to apply business analytics tool, like how to apply statistical tool to different business area. Then you will be learning predictive analytics, which I told, predictive analytics in Python, and you will be able to solve classification of types and problems in Python. So these are the 7 hands-on skills. I'm giving you here a hands-on skills. Mind it, only hands-on skills here. Okay. So with this, I think I'm done, and I open it for question and answers. So if you have any kind of question, any query, I think you can ask. And Soman, how many people we have today?
So right now we have 28 participants.
So I think more people joined, right?
Yeah, a few left, I think.
So what was the maximum number today?
I saw 33 maximum.
Okay, not bad. So 23 stayed means 23 are having some kind of interest. So till first 2 weeks I will observe. I want to observe like who is sticking and who is not sticking. So persons who will stay on after 2 weeks will be taken more. Those guys will be taken more seriously. Okay. So this is how it is. And if you have any kind of questions, today I cover very basic things. Very basic things. Assuming that you guys don't know anything about machine learning. So very basic things I have covered today. So if you have any doubt, you can ask. Otherwise, anyway, we'll be covering it when we'll cover linear regression and logistic regression. Anyway, we'll be covering all these things once again. So on more better form, in a quantitative form. So with code we'll be covering. So you will anyway understand all these things. But today, today was pure theoretical class to give you a feel of machine learning. So if anybody has any kind of questions or any doubts about anything or machine learning or like any other doubt you want to ask me, any question, you are welcome. So if you want, I will stop the recording so that any question you can ask me, any damn question.
Sir, I think there is a question on the chat. Someone has asked, can you explain more about unsupervised learning?
Yeah, I'll explain once again unsupervised learning. So, like I will explain unsupervised. Very nice. You at least asked the question. I'm happy. So, screen is visible, right?
Yes, sir.
Yes.
See, first I'll explain the supervised learning. So, supervised learning means my machine learning program remains the same. Machine learning program. In supervised learning, what I do, I supply data with labels. Data means my data is images and I supply it with labels. Labels means it is a cat, it is a dog, cat, dog, V sign, phi sign, motor, car, all these are labels. Means I supply data and I give answers also. I give answers also to the computer. Why I am doing this? It is for training. So label means answers. I am giving answers also. So with answers I am feeding data to the computer. Now computer gets trained, and when I give you when I give machine learning program a new figure, then I am not giving answer because I am not giving answer. So unknown figure I am giving. But as it is trained, it will be recognized as a cat, dog, or whatever it is. Whatever image it is, it will be able to classify. But accuracy is never 100%. Accuracy 80%, 90%. If you are above 90%, you are king. But generally in machine learning, we look for 80% accuracy. Or below, if you want to go like minimum 70%, and 80% is accepted, and above 90% is excellent. That's how is the percentage of accuracy. Some misclassification will happen. But if we are making a machine learning program, we want to make sure that at least 70% are correctly classified. 80% is acceptable. And so here I am giving images with labels. Now you come here. I am giving only these pictures to this picture only I am giving to computer. I am not telling which is potato, which is what. There are 3 types of vegetables you can see, right? Different colors, 3 vegetables. So I am not telling computer which is what. I am not giving any answer. I am not telling computer which is potato, which is vegetable 2, which is vegetable 3. I am not telling computer. I am giving only this computer. I am telling, I am giving only the left hand side figure to the computer. I am telling computer program to make 3 clusters. Similar vegetables should be in similar cluster. So computer program, there are some clustering type of algorithms which take similar feature in mind, and similar they segregate similar kind of like you see. So here there are groups now. You can see that here vegetables are all mixed in left hand figure, but right hand figure you can see the groups. Right, understood. So how these groups have happened? Computer has seen color, computer has seen the average shape, the computer has seen the weight. Those kind of details were fed into the computer. Weight, color, average shape, average size, those kind of volume, average volume of the vegetable, those kind of things were fed into the computer. So based on similarity, computer has like make different cluster. So there, I think ideally it would have shown 3 clusters, but it is showing only two clusters. So there are 3 kind of vegetables I see. I want to see 3 clusters here, but only 2 are shown here. Is it clear? Is it clear now? I don't give any kind of level or any kind of answer. I don't give to the computer. And I want computer to make clusters, segmentation. So is that okay? Who asked this question?
Sir, on the chat it says yes, it's clear now.
Very nice.
Sir,
Anybody, any more question?
Sir, I have a question. In
Yeah,
normally industry deployed algorithms like production,
Yeah.
what is the kind of accuracy that they look at?
Madam, 80 minimum they will look. But if it is a very high value application like credit cards, right?
Okay.
So credit cards, they want you to classify fraud and non-fraud transaction with the accuracy of more than 90%.
Okay.
Because if you give 80% accuracy, if you give 90% accuracy, the loss to the bank in 80% will be few $1 million more than 90% accuracy.
Okay.
So it depends on the application.
Okay. I guess even in healthcare they look for.
Yeah, healthcare also they look for very high accuracy.
Okay.
And usually traditional machine learning programs, you will get accuracy between 80 to 90%. That's my experience.
Okay.
But these kind of neural networks, which I am showing here inside these kind of neural networks, you get accuracy above 90%. And there is a technique called transfer learning. There is a technique called transfer learning in which somebody has to go on mute, please. Voice is coming. Mute, please. So in deep learning or transfer learning is a technique where you get pre-trained model. You cannot train those models in your house or your laboratory because it requires massive kind of computer resources to get trained. Some hundreds of computers will work in parallel and they will take some months to train that machine learning program. So those kind of resources only Google's, Amazon and Microsoft only will have those kind of resources. Any company, any institute will not have those kind of resources. So Microsoft, Google and all these people, they train, they pre-train those kind of models. So all this kind of images, no? So 10,000 images, they will train program they will pre-train one program, deep neural network. One deep neural network, they will train to identify 10,000 type of different things. They will pre-train. So those kind of pre-train, that is called transfer learning. That is transfer of knowledge. So training has happened in Google, but you are using in your house. At home you are using that, but training of that algorithm has happened in Google. So it is nothing but a transfer of knowledge. That is called transfer learning. So in this kind of transfer learning, usually you get accuracy above 95% and all.
Okay, sir.
So Google, Microsoft, and there are many other companies like Elon Musk company, OpenAI, Google, Microsoft, they have done a lot of this kind of pre-trained networks and they have given it in the open source which you can use. So we'll be having one complete class and complete exercises on transfer learning also. So I'll teach you how to learn those pre-trained models. That programming is very easier than programming a neural network at home. Transfer learning programming is very easier because all the layers are trained. Only last layer or last two or three layers you have to remove. and you have to train them. That's all. All model is trained itself. And if somebody asks you to train that model, you cannot train also, because you don't have that kind of data. You don't have those kind of computing resources, massive computing resources. So transfer learning is much easier than training a normal neural network, and it gives very high kind of accuracy.
Okay, sir.
So these kind of pre-trained neural networks are different for mobile phones. They are different for different kind of application. You have different kind of pre-trained networks. So that you should know that in what situation, what kind of pre-trained network you have to download. Once you know that, you download that pre-trained network. Just change the last layer. Suppose he has trained it for 10,000 objects. So you will have 10,000 neurons in the last layer, and you have to classify only 4 objects. So you remove that layer with 10,000 neurons and put only 4 neurons in the last layer, and you retrain it. Within half an hour, you will be able to retrain it, and nice accuracy, very fantastic accuracy you will get, 95%, 98%, like that accuracy you will get. Because training has already happened in Google or Microsoft or Amazon, and they have transferred that knowledge to you. So what is knowledge? Knowledge is nothing but it is all mathematics. Okay, knowledge is stored in the form of mathematical equations in the neural network also. So what is knowledge? Knowledge is nothing but weights and biases. I'll teach you everything. Knowledge is nothing but weights and biases of the neural network. Every node which you are seeing here, green node and blue node in this inside computer, there is one network, right? In that you are seeing blue node and green node. It is called neurons. So each neuron will have weight and bias. Each neuron will have weight and bias. So those weights and biases are the key things which a neural network learns, and based on that only it recognizes whether it is a cat, whether it is a dog, or those kind of things. That is knowledge. Knowledge is stored in the form of network architecture. Knowledge is stored in the form of weights and values of weights and biases. So they are training it at Google and transferring it to you for open source. They will not transfer you all their models. Secret models they will not transfer you, but some very good models are available in open network also. Some very good models are available which you can use. Like VGG16 is a pre-trained network. VGG16, it came from Oxford University. VGG16, it came as recent as 2010. OpenAI, some models are GPT-3. GPT-3 came in 2020 only. 2020 only it came. Recent, less than a year it is available. So those kind of models are very recent. Some models are developed in 2017, 2019. It is a very recent knowledge which you can use. It is available in the open source. Okay.
Yes.
So very interesting to learn, and very kind of easy to program, and very interesting to learn if you are doing little bit hard work. Very nice things you will be able to do with this with the help of these things. So any more questions? We'll stop for a couple of more minutes. Next class will be tomorrow 4 o'clock, and we'll start with little bit algorithm. We'll start with simple linear regression. Simple linear regression will start tomorrow. So there will be one half an hour class, and after that there will be one coding class. So coding will be first explained to you in the class, and after that one small assignment will be given to you for homework. So we'll have maximum 3 classes a week. Out of which 2 will be on Saturday, Sunday, and 1 will be on weekday. So weekday class will be at night 9 p.m. so that everybody is free at that time. Only 1 class will be there on weekday. 2 classes will be there on Saturday, Sundays. Maximum 3 classes a week, and maximum duration of 1 class will be 2 hours, not more than that. So today I think we have not taken more than 1.15 hour or like that. Very less time we have taken today. So that's it. I will wait for a couple of more minutes.